Hey everybody. Today we're going to talk about, you can see on the screen, the equation of a circle. So we've spent some time over the last bit coming up with how do we graph lines, how do we graph curves. Today we're going to address what does the equation look like that would construct a circle. Okay, I want to jump right in. So what we're going to do is we're going to go through a process to discover the equation like you see on the top of the screen. What this is going to be is a bit of a proof for us. We want to make sure that we understand why the equation of a circle is what it is. So it's not just something that we memorize. So what I want to do is I'm going to start with the premise that we're going to build a circle that has a center 0, 0. So what I'm going to do on my set of axes, and I'd like you to do the same, we're going to put a point and we're going to call it C. Now, because it's at the origin, we shouldn't have to label that it's 0, 0. But if it helps you, put on the actual coordinates. Okay. Now, what we're going to do is we're going to use the key component that builds a circle. That is, if I was to ask you right now, draw a perfect circle, then I hope what you'd be reaching for is a compass. Or if we were about to walk outside, you'd be grabbing a stick and a piece of string to make sure that you could have an accurate radius. For us to build a circle, we're going to use a radius. So we're going to plant one end at the center, at 0, 0, and then we're going to take another point. We'll just call this like length of our radius, some, unknown amount. And let's say that if we were to stretch that radius, and just for the ease of like our picture, let's go ahead and put it out into quadrant 1. So if we were to put it into quadrant 1, I'm going to call that green line maybe my circle. Or sorry, my radius. And if I were to do that, and I'm just going to actually shorten it up a little bit because I think it might just go a little too long for my visual, then that would end up giving me the beginnings of a circle. What I would then do is I would take the very end of that and I would now rotate it around, and we'll see how good hey, that's not too bad. And I would rotate that around and it would construct a circle. Okay, I want to get rid of all that green that I just drew with the exception of our radius. What I can do then is I can say that at the end of that green line, that radius, I'm going to put on a generic point. And we should be comfortable by now to just be able to denote generic points as point XY. So I'll call it point P and it has coordinates XY. I want to make it generic because of what I did earlier. Now, point P, maybe it really exists here, or maybe it really exists here, or maybe here, maybe. It doesn't have to be in quadrant 1. It could be anywhere because I've just said it has coordinates x, y. And so if it holds any of those points, and that's a way worse circle, then it would construct a circle. So I'm going to get rid of that really horrible circle one more time and just be left with point P. So if point P exists anywhere, then I'm hoping we can see how a circle would be constructed. Okay, well, what can we do? Well, we do know one key feature of that. We do know that the length of that green would be the radius of our circle. And last time we worked through how to come up with the length of a line segment. So what we can do today is we can come up with the length of R. We could say that R, our radius, is going to equal the length of the line segment that would run from P to C. So we should be good that the length of our line segment is the square root of. Now, that r is going to be the hypotenuse of my right triangle. And I'm just going to drop in my right triangle so I can see a little bit. That what we're talking about then, to get the horizontal side, well, that horizontal side would then be the difference between x subtract 0, since my center is at 0, 0. I'm just going to write that in just so we can see it. But we should be good that really that horizontal side just has a length of x. Plus, and now I'm hoping we're okay with the same thing on the vertical side, that it would be y minus 0. And same thing, if we were to look, we went up y units. Now, you'll see in a moment why I put in the zeros, but I really wanted us to make sure that we understood where we were getting those values. Okay, I'm just going to switch to gold over on the right side because we can now simplify that down to everything we just spoke about. There is my x squared plus y squared. Okay, here's the problem. We don't know what x and y are, nor do we want to. We want that point to be generic so that it could exist anywhere at the end of that radius and therefore form a circle. But the form of that you see in gold isn't as useful as maybe it could be, or maybe if I had to simplify, it's not as clean as what it could be. If I wanted to get rid of that big ugly square root, then what I could do on the right side is I could square everything. But we should be good that if I'm going to do that on the right side, then I have to do that on the left side. And the only reason I'm doing that is to get rid of that square root again, just to clean it up. So if I was to do that blue, then I come in on that final gold line, and believe it or not, that represents the equation of a circle. Now, that represents the equation of a circle with some pretty specific things. First off, it only represents the equation of a circle that has a center at 0, 0. Notice that was a key component of what we talked about at the very beginning. We started our circle from the origin. The other part, to make a note of, it also means that we have a radius of r. Okay, you will see that form for the equation of a circle, and then I'm hoping that we're also very good, that if r squared equals x squared plus y squared, then, and I'm just going to jot this down really fast, then x squared plus y squared also equals r squared. We get the idea. We could frame it in either direction. Okay, there you go. Now, all I'm going to do is just clean up our diagram a little bit. I'm going to get rid of that extra form, and to go back up to the very beginning, I'm going to get rid of that red that I put on. Just because where we're going to go with this is a little bit of an extension. Okay, what you need to remember is that the equation of any circle with a center 0, 0 and a radius r is x squared plus y squared equals r squared. Okay, we're going to use that and we'll get some time getting very comfortable with that. What I want to do, though, is I want to jump into a little bit of an extension. So what we're going to do is we're going to go a little more general. You can see that what I did at the top of the screen was I just changed it from discovering the equation. We're going to go through and figure out the general equation now. So what I mean by that when I say the general equation is I don't just want my equation to be for centers or circles centered 0, 0. I want it to be center anywhere. Now, I need you to know that this is above the level of the course, but I think it is so manageable for you, why not discuss it? So what I'm going to do is I'm going to go through that same process, but just do it a little quicker. Okay, let's say that rather than setting my center at 0, 0, I put it over here in quadrant 3. Now, the reason I'm putting it in quadrant 3 is just to help my picture. That's all. To fit everything in. I'm going to call that my center, but because it's not my origin anymore, I'm going to label it with a different set of coordinates. Now, you'll see in a moment while I'm doing this, I'm going to call my center H and K. Okay, I'm going to leave that as my center, but what I'm going to do is I'm going to do the same thing as what we did before. I am now going to construct a radius, and I'll do something very similar to before. I'll extend that radius up into quadrant 1, and maybe we go that far. Now, it is generic, so that center is at HK, and the end point that I just put on is going to be at XY. So we could now take that radius, of which I will call again R, and I will do the best I can with my picture. I am going to say that point P could exist anywhere. Oh my goodness, this is going to be a bad one. Anywhere so that, well, like clearly what I'm about to draw on, that does not look like R. It looks a lot shorter, but you get the idea. It's also R. That now we will end up creating a circle that exists anywhere with a radius of R from a center of HK. Okay, we could do the exact same process. We know that that radius is the length of the line segment from, okay, C to P, or P to C. So if I was to drop in my vertical and horizontal components, I can see that the distance that I have to go horizontally has to run from X back to H. So I need to subtract it. I know that my vertical component has to run from Y down to K. So I subtract them. And now we could just use Pythagorean theorem and we could say that my horizontal side squared plus my vertical side squared has to give me the length of my line segment. Okay, everything that we did before. Let's get rid of that ugly root. Like, we don't like that. It's not as clean. So I'm going to square the right side, and to square the right side, as long as I square the left side, I am good. And what you can now come up with is your generic equation. R squared is going to equal x minus h squared plus y minus k squared. And that represents a circle with a center anywhere. We would just call that center H and K. And a radius of R. So when you take a peek at that, I can now sneak in there is the center of my circle. Okay, so we're not going to get as much practice with that as what we would with the other, because again, it is above the level of the course. But if you were trying to play through on Desmos to go through some problem-solving activities, then maybe knowing the general form for the equation of a circle might be a little more useful than just being stuck with circles centered 0, 0. Okay, again, above the level of our course, but I think it is more than manageable for you. Okay, what I want to spend the rest of the day doing is jumping back and working with the general form for equation of a circle with the center at 0, 0, and us getting comfortable at all the parts of it. Okay, here we go. Now, what you can see on the screen I've asked you in question 1a to write an equation for the circle with a center 0, 0 and a radius of 8. And then in point B, problem B, I want you to list 5 points on its circumference. Okay, so what I want you to do, take a moment to copy those 2 problems down, and then I want you to give problem A a shot. Okay, give it a shot on your own. Pause the video now. Okay, we're back. So to take a look at problem A, this is what I'm talking about getting comfortable with the equation. I should know now that the equation of any circle centered 0, 0 takes the form x squared plus y squared equals r squared. That's almost like my formula for the equation of a circle. So I know that I've already used up that part by writing just x squared plus y squared. What I haven't done is used up that key component. My circle needs a radius of 8. So what I could do is I could sub in my r value of 8. Now, there's one part of that equation that we can simplify, so I would expect to see you calculate that 8 squared. There is my equation of my circle with a center 0, 0, radius 8, simplified. There we go. Hopefully not too bad, and hopefully we matched up. Okay, for part B, what I want you to do now is I want you to try to come up with 5 points that would lie on its circumference. So that's just another way of saying 5 points that would lie on that circle. Okay, I want you to give it a go. Pause the video now. Okay, we're back. So if we were having a little bit of difficulty, then maybe we went through and we drew a picture. So if I have a circle with a center at 0, 0 and a radius of 8, and I'm going to do my best to draw my picture, my circle here. Yeah, that's not too bad. I'm pretty happy with that one. Then what you're trying to come up with is the coordinates of 5 points that would lie on that circle. Okay? So I think that might clarify something, and I want to give you another shot to give it a go. So we're going to pause the video, and when we come back, I think we're going to see some points listed. Okay, pause the video now. Okay, we're back. So you can see that I've listed out 4 points that we found on the circumference of that circle. And I recognize how incorrect this is that I'm saying it this way. But my guess would be if you found 4 points on that thing, you probably found its corners. And I understand that a circle cannot have corners, but what I really mean is we probably stretched out our radius. If you look at my diagram, if I know that that's 8 units, then we probably found this far edge or point at 8, 0, and then we probably did the same thing in every direction. We went up 8 to the top, 8 to the bottom, 8 to the side. I don't need to label all those points out. You can start to see where they exist, and you can see how I got my 4 green points. Okay, I'm just going to erase that stuff off my diagram. Those would be the points that I would expect us to have. But in the problem, I asked you to come up with 5. And I asked you to come up with 5 to guarantee that we're going to have to do something. That we can't just use the radius and go horizontal and vertical from there. So how can we go about finding our 5th point? Well, I want you to take a look back up in A. Because remember, what I just boxed in right now, that is the equation of the circle. That is the equation that represents all of the points that lie on that gold circle. So let's use the equation then to find another point. So what I can do is I can just pick an x value where I know that circle would exist. And I could pick any x value as long as I'm not picking 0, or plus or minus 8, because I've already used those on the 4 points I have. So I'm going to just pick something that works, and I know, for instance, that 1 will work. If I go, and you look at my diagram, to an x value of maybe like 1, I know that I have a point up here and I have a point down here. So I know that a point is going to exist on that circle. So if I went through and I just subbed in an x value of 1, well, then I'm going to get 1 squared is 1 plus y squared equals 64. Well, look what I just have. I now have an equation with one variable. I can solve it for y. So I'm just going to sneak this up here. My y squared is going to give me 63. And so my y is going to equal plus or minus, because to get rid of the squared, I got to take the square root, and I know I always get 2 answers, and I get root 63. Now, for me to simplify that, 63 is a 9 times 7, and I can take the square root of 9, so that is plus or minus 3 root 7. Now, notice that my 1x value gave me 2 different y values. Why is that the case? If you look over onto my diagram, you'll see that what I end up having is 2 possible points. That is, when I solved my equation, I found both possible x values. I could have a point up here with an x value of 1 like we subbed in, and a y value of 3 root 7. Or I could have the point down here, which also had the x value of 1, but had a y value of negative 3 root 7. You'll notice by me solving my blue equation, I find both x values at the same time. Now, you did not have to sub in 1. You could have subbed in 2, subbed in 3, subbed in negative 1, negative, whatever. Okay, I'm kind of leading you in. Can you take a look at the question I posed in C? Could we choose an x value of 10? Now, I'm hoping you take a look at the picture to that circle on the right, and I hope our answer pretty quickly is no. Can you please look at that circle as I zoom in on it? If we were to pick an x value of 10, are we good that my x value of 10 would have to be out here somewhere? Remember, the radius of that circle is only 8. So 10 would put us outside the circle. And I'm hoping, because we see we're outside the circle, pretty quickly you would go, no, we couldn't choose 10. Okay, I want us to walk through what would that look like if we did choose 10. Okay, I'm going to do the same thing. I'm going to sub in an x value of 10. So that becomes x squared, so 10 squared is 100, plus y squared equals my r squared, which was 64. Okay, now I got to solve for y, so I'm going to get rid of that plus 100, and when I get rid of my plus 100, I minus 100, and right there you might be able to see we have a problem. How can I ever have a perfect square that gives me a negative value? I can't. I have a problem with this equation. Okay, what if we don't see it there? Then I'm really hoping we see it here. To get rid of the squared, I take the square root, but now I'm trying to take the square root of negative 36, and we should be good that you cannot take the square root of a negative number. So that's what that looks like if we tried to find a y value outside our circle. What would our statement be to the end of that? It would actually be that there is no solution to that equation. And therefore, there is no point with an x value of 10. Ooh, that is really sloppy in the end. I was trying to just copy it down quickly, but there we go. There is no point with a y value or an x value of 10. So if we were to ever choose an x value that was outside our circle, like we didn't really clue into what we were working with, or we were just unaware of some of the detail, if that ever pops up, the orange pops up, we now know how to interpret that. Okay, I'm just going to shrink that down so we can see all of question 1. There's us just getting comfortable working with the equation of a circle. X squared plus y squared equals r squared. We were able to sub in a radius, we were able to find points on the circle, and we were able to find when we had no points on the circle. Okay, I want to keep things going with working with the equation of a circle. Okay, what if we took a different approach? Take a look at problem 2. What is the radius of, and I've given you part A and part B, I've given you 2 equations. I am hoping that you could go through and answer both of those. So what I want you to do, pause the video now and tell me what is the radius of each one of those circles. Okay, pause it now. No, okay, we're back. So if we know that equations that take the form of x squared plus y squared equals a number represent equations of circles with center 0, 0, then we need to know that that number, the constant, is the radius squared. So you could take a look at equation A and you could say that you know that r squared has to give you 36. And if r squared has to give you 36, then your radius must be 6. Now, I want to address a number of things on problem A. First off, if you created the green, you may then go, yeah, but like, why isn't it plus or minus 6? And there is a little bit of shortcutting that we tend to do. That when you're going through and you're finding a length, in this case a radius, you can't have a length of negative 6. Like there is no such thing as a length of negative 6. If anybody wants to go, yes, there is, you just go backwards 6, then I want to slap you. Of course you can. It's still a length of 6. You can't do that. Okay. It doesn't matter direction. So what we tend to do as we work our way through is we tend to just deal with the positive. So if you gave me the green, great. However, I would be totally fine with you just looking at the equation, recognizing what I just boxed in gold, that is a circle. And if you recognize it's a circle, then you should be able to recognize that 36 is r squared. If you honestly just said radius equals 6 and you just gave me what I just boxed in on the bottom, then you are 100% correct. I would never need to see anything else. Okay, I think that should clarify then what I would expect to see from a solution. So take a look at B. If we recognize that is a circle because it's x squared plus y squared equals a number, then that number has to be our radius squared. I am fine if you just told me it's got to be the square root of 70. Now, I'm hoping we're pretty good, that 70 is just a 7 times a 10. Neither of those would reduce. So you could just give me the gold and you are perfect. You don't need to give me anything else for a solution. Okay, hopefully that went well. And we're getting more and more comfortable with working with the equation of a circle. Okay, I want to work through one more problem with us getting comfortable with that equation. Okay, what I want you to do is to work through problem 3A and B on your own. Okay, I want to see if we can come back and see how well we match up. Okay, so when you pause the video, copy out the question and then give it a shot. Okay, pause it now. Okay, we're back. So, the question in 3a said, determine the radius of a circle with a center 0, 0 and passing through the point 4, 5. Okay, so what could you do? Well, to determine the radius of the circle, that's what the question's asking me for, then really I want to know how far is it from 0, 0 to 4, 5. So if I need to know how far is that, then what I'm going to do is I'm going to find the length of that line segment. So I might look at it and say, well, there's my radius, and I know my radius would be the length of the line that is the hypotenuse on a right triangle. Maybe you jotted down a quick picture and said, I'm going from 0, 0 out to 4, 5, so you can see that radius. If that makes it easier to be able to see that we are going 4 across and 5 up, then by all means, use your diagram. But I would have had a number of people that would have felt comfortable to just go ahead and jump in right there. In fact, they may have chosen to already square the 4, square the 5, and all we had to do was simplify that to your 41. There we go. So if you have a radius of root 41, outstanding. Okay, take a look at question B. Question B was write the equation of the circle. Okay, everybody should then be comfortable to be able to go through and say, well, if I know that my radius is root 41, then my equation of my circle has to be x squared plus y squared equals 41. Because it would be the root 41 squared, which gets me back to 41. Okay, that would have been one way to go through and deal with that problem. What I want to do is I want to deal with it a different way. To do that, I'm just going to get rid of my picture. So I'm going to get rid of the diagram I used in the blue solution because I may have actually tackled this problem a different way. And that I might have been comfortable to actually do part B first, then backtrack to answer A. Okay, how could I have done that? Well, if I know that all equations with a center 0, 0 for circles take the form x squared plus y squared equals r squared, then what I could have done was I could have said, oh, well, okay, I'm now going to sub in the full point 4, 5. If that's a point on my circle, I'm going to sub that in. And by doing that, I now get 4 squared plus 5 squared equals my r squared. That we may have come in on r squared equals 41 first. That, of course, allows you to jump back to part A, and you could tell me then that it has a radius of root 41. And pretty quickly then, you could have answered part B by giving the full equation of that circle as your x squared plus y squared equals 41. So 2 different approaches to problem 3. Maybe you take the blue, you find the radius first, you use that to find the circle. Maybe you take the equation of the circle first. You use that to find r squared, which allows you to find the radius. And now it's just a matter of stating the equation of the circle. 2 different ways. So if you used either one of those, great. And I think that's giving you some comfort, some information that says that you're pretty comfortable with the equation of a circle. Okay, I want to jump into one last problem. Okay, you can see the problem on your screen. This is our last one for today. And I think that this is a pretty good problem for us to be able to work through because it incorporates a lot of different things. I would like to know, where does the line y equals 3x minus 5 intersect the circle x squared plus y squared equals 25. And I want you to provide a sketch. Okay, I think that this is a problem-solving question. I think it is a great question for you. And if you are comfortable to work through solving this problem, I think this is giving you great feedback for your algebra. Okay, I want you to give it a shot on your own. Okay, pause the video now. Okay, we're back. I'm going to maybe deal with this one maybe backwards in a way. And all I mean by that is I'm going to go ahead and provide a sketch at the very beginning just to have a better sense of what I'm working through. So there's my set of axes. If I take a look at my circle is x squared plus y squared equals 25. I should be good that that circle then has to have a center of 0, 0 and a radius of 5. Because I see that 25 on the end, and I know that that's r squared, the radius squared. Okay. And then up here, I've got this line. And I know that the line y equals 3x minus 5 has to have a y-intercept of -5 and a slope of 3. So if I was to go through and try to imagine, like I'll take a y-intercept of -5, but then I got to make it a little steeper than 1, then maybe what I do is I draw on my blue line, and maybe I get something like that. So I know that I'm going to hit the bottom of that circle at -5 because I know the circle has a radius of 5. I know that my blue line is going to hit that circle at -5 because it has a y-intercept of -5. So just by sketching, I know that I found one point of intersection, 0, -5. What I'm missing, though, is this point up here. I don't know the location of that red point. So what I'm looking for is, where does my line intersect the circle? Okay, if that helps to give you a better frame of mind, then I think that this is an opportunity to pause the video now and see if you can finish it off. Okay, otherwise you're coming along with me. Well, I'm hoping that we remember that to find the intersection points between things, that means for us to solve a system. Yeah, we're going back to Unit 2. So for me to solve the system on that, then maybe what I'm going to do is I'm going to call equation 1 my line, and I'll call equation 2 my circle. So what I could do then is I could sub equation 1 into equation 2. Okay, for me to sub equation 1 into equation 2, I am going to replace my y with what it is equal to. And you can see that what I've copied out in orange then is equation 2, except I replaced my y with 3x minus 5. Because in equation 1, it tells me y equals 3x minus 5. Okay, look at what I just built in orange. I just built an equation with x's. And I am hoping that we are comfortable to solve that equation. So this gives you a little bit of review from Unit 3. Are you comfortable to go through and solve that quadratic equation? Okay, I want you to pause the video now if I caught up to you, and I want you to see if you can finish that off on your own. Okay, pause it now. Otherwise, you're coming along with me. Okay, we should be comfortable to go ahead and expand all of our brackets. I'm doing that so I can collect like terms. When I put my x's on one side, I notice that my 25s are going to cancel out. So that gets me an equals 0. I cannot collect my x's into one variable term. So now I'm going to look to factor. And this one works out really well because I can factor it by pulling out a common factor of 10x. That leaves me with another factor of x minus 3. And so I get a solution of x equals 0 from my first factor or 3 from my second. Okay, I want to stop there for a second and just get us to take a look at our picture so we can get a little confirmation on something. I just found one of my points of intersection was that orange one that has an x value of 0. And notice, we actually just found our first point of intersection. That confirms it. Nice. But if you look up at the red point, what I also now just found was that point of intersection occurs at an x value of 3. I just don't know my y value. So I'm on the way to finding my points of intersection. Okay, what I'm going to do now is I'm going to finish off that problem. Okay, I'm going to just erase a little bit of that orange on my diagram, and now I'm going to work my way through. So my advice to you would be, use your communication statement here to organize your solution. What I'm now going to do is I'm going to use, or sub, x equals 0 back into one of my original equations, and equation 1 is absolutely the easier one. When I do that, now I'm going to get y equals 3 times 0 is 0, and there's my negative 5. So I just found I have a point of intersection at 0, negative 5. That's what I had on my diagram. Perfect. What I'm also going to do is sub in the other x value I found, and I will sub it back into equation 1 as well. That now gives me a 3 times 3, which is 9, and there's my 4. I found my other point of intersection now at 3, 4. So if you look up at my diagram, I've now answered that problem. I found both points of intersection. That is great. Look at that problem. That's one that kind of incorporates a little of this unit with the equation of a circle, with some of the stuff in the last unit being able to solve our quadratic equations. Perfect. Okay, your goal for today is to get comfortable working with the equation of a circle. Okay, I want you to jump into your practice. Best of luck.